we're talking about prime factors here, and they differ just a little bit from factors, because remember in the last video we talked about factors, and they were just any two numbers to multiply to get to that number we're wanting. So if I talked about just factors of 12, I'm not even talking about prime factors, we're just doing a little review here. Factors of 12, that would be 1 and 12, 2 and 6, 3 and 4, right? Well, are these prime? Think back to when we did prime. Prime means that they only have two factors. 1 is not prime. 1 is actually neither prime nor composite. 2 is prime. 3 is prime. But 4 is not prime. When we want prime factors, we want a product of prime numbers that multiply to get to 12. This isn't even a product. This is a list. When you want factors, you have a list. When you want prime factors, you're going to have a product. Product means multiplication. So we're not wanting this. This is just a little reminder of what this is, what factors are. I want prime factors. So they all need to be made up of 2s, 3s, 5s, 7s, 11s, etc. Okay? But how do we get there? We're going to use something called a factor tree. That's something we're going to use to get to our, find our prime factors of 12. So I'm going to start here with number 12, and then I'm going to make a little branches, and I'm going to say, give me 2 things to multiply to get 12 besides 1 and 12, because those don't get us anywhere. So what's 2 numbers to get to 12? Well, we could get to 2 and 6, or some people might have said 3 and 4, and that's perfectly fine. You can use either one to start with. So I'm going to start with the 2 and 6, and then we start asking ourselves, are either one of these prime? 2 is prime, so I'm going to circle it and stop right there. So 12 equals 2 times what? The 6, I can break it down into 2 times 3. And those are both prime. So this can be written as 2 times 2 times 3. And that would be right here, 2 times 2 times 3. That would be our prime factors. This is what we're looking for when we say prime factorization. We're wanting to know how you multiply with primes to get to 12. We're going to do the same thing for 28. So I'm going to start with 28, and I'm going to say, what are 2 things to multiply to get to 28? Well, 2 times 14. 2 is prime. 14 is not, so I can break it down, and it can be 2 times 7. And these are both prime also. As you can see, I like to circle my prime numbers, because sometimes, just like Christmas trees, when you're taking all your ornaments down, you can leave that ornament. It gets hung up there in the branches. So sometimes, and we might see it over here with 240, how they get lost up there in the tree. So you want to make sure you know all your primes. So when I sit here and I go 2 times 2 times 7, I will quickly mentally just multiply these together to make sure it does equal 28, to make sure we didn't leave one of those prime factors hanging out in the tree. So 2 times 2 is 4, 4 times 7 is 28. We got that. There are our prime factors of 28. Now I move over here to 240, because some of y'all go, okay, I got it for 12, I got it for 28, but when we start getting to 3-digit numbers, y'all all start to panic, which we're not going to panic. We're just going to think about divisibility rules. And we look at 240, and what's some numbers that you know can divide into 240 very easily? Well, 2, because it ends in a 0, and any number that ends in a 0, 2, 4, 6, or 8 is divisible by 2. But what other types of numbers can be divided by when you end in a 0, or that you can divide by when you end in 0? We could divide by a 10. So I'm going to start with that. We could also divide by 5, but 10 makes it a lot simpler and easier real quick. So I'm going to start here, and I'm going to go 10 times 24. So any number that ends in 0 can be divisible by 10 very easily. So is 10 prime? Nope. We got to go 2 times 5. So I circle my 2 and I circle my 5. They're there. And then we have 24, which is 2 times 12. Or we could have said 4 times 6. Either one. And 2 is prime. And then we have 12, which is 2 times 6. And we keep going until we get all prime numbers. So now I have 1, 2, 3, 4, 5, 6 factors, prime factors. And I'm going to write these in order from least to smallest. So I have 1, 2, 3, 4 factors of 2, a factor of 3, and a factor of 5. If I multiply all this back up, 2 times 2 is 4, 4 times 4 is 16, 16 times 15 should be 240, okay? 16 times 15, yeah. All right, so there's another way we can write this, and I'm not sure if Connect Math wants you to write, but it's, you know, free extra information. If we have repeating factors, what I mean by repeating factors, I have 2 2's here, I have 2 2's there, I have 4 2's there. Those are repeating factors. I can write them in exponential form. I'm going to start with this one because it's a little bit easier to see. I have 4 factors of 2, right? So I can write down my base that's being repeated is the 2. How many factors of 2 did I say we had? 4. We put a little exponent up here to represent I have 4 factors of 2 times 3 times 5. Now over here we have the base is 2 because that's what's being repeated. I have 2. And how many of those do I have? I have 1, 2. So I put 2 there times 7. And over here we have 2 to the second times 3. Okay. All right. Have fun.